Hello students, in the last class, in the last video, we discussed maxima and minima. We have seen what is the condition for y becoming maximum at a particular value of x, and also we discussed condition for y becoming minimum. We have seen some applications of maxima and minima also. We discussed how to apply the concept of maxima and minima in physics. Now let us discuss how to draw a graph when a function is given. So when a function is given, how do we draw a graph? A function is basically the relation between two variables, x and y. X is independent variable, y is dependent variable. In physics, they are physical quantities. When x changes, y changes. So from the given function, from the given equation, we gather all the information required to draw a graph. So what do we mean by all the information required to draw a graph? Is y increasing as x is increasing? Is y increasing at an increasing rate or decreasing rate? If y is decreasing, is y decreasing at an increasing rate or decreasing rate? Are there turning points in the graph? So like this, turning points means maxima, minima. Like this, we gather all the information required to draw a graph. So I consolidated that information into some 4 or 5 points here. So first I'll write down those points. Before we draw a graph, whenever a function is given, you need to keep these points in mind. So I'll call them checkpoints. The first one is to always find slope. Why do we do that? When we find the slope, we understand if the slope is positive or negative, is y increasing or decreasing, is y increasing at a constant slope with a constant slope. So all that, so y increases at what rate or y decreases at what rate. So to understand that, we need to find slope or dy by dx. That's the first checkpoint, we can say. Next, check if there are turning points in the graph. Turning points, I mean inflection points. Does y become maximum at any given value of x? Does y become minimum at any particular value of x? So that's what we need to verify. The third one is the value of y. Find the value of y at x is equal to 0. I mean y-intercept and x-intercept. Find x and y-intercepts. The next one is find what happens to y as x tends to plus infinity or minus infinity. As x tends to plus infinity, what is happening to y? As x tends to minus infinity, what is happening to y? X-intercept means y becomes equal to 0 at what value of x? Y-intercept means x becomes equal to 0 at what value of y? So if you find this information, if you gather this information from the given function, it means you have almost all the information required to draw a graph. So you don't have to put data points in the graph to draw the graph. Okay, so just gather this information. This information is almost sufficient to draw a graph This information gives us the qualitative behavior of the function. This information tells us if y is increasing as x is increasing. This also tells us is y increasing at an increasing rate or decreasing rate. This information also tells us if there are any turning points in the graph. It means y becomes maximum or minimum in the graph. Okay. This also tells us what happens to the value of y as x becomes 0, and what happens to y as x tends to plus infinity or minus infinity. Right? So by gathering this information, we understand now how to draw the graph. Let's see some examples. I'll give you one simple example here. Let us draw graphs of some functions. Look at this first example, y is equal to 2x plus 4. How do we draw the graph? First, find out the slope. If you find the slope, you will primarily know whether the graph is drawn with a constant slope, increasing slope, decreasing slope, positive slope, negative slope. So first find out the slope, or dy by dx. If you find dy by dx, if you differentiate this, you will get 2. It's a positive slope and constant slope. Positive slope means y increases as x increases. But at what rate y is increasing as x is increasing? At a constant rate. At a uniform rate, y increases as x increases. You know, if y increases at a constant rate, then the graph is a straight line. It's a straight line graph. Okay, passing through what points? Look, this is the first checkpoint. Now the second checkpoint, inflection points don't exist. It's a monotonic graph. As x increases, y increases. As x decreases, y decreases continuously. There are no turning points in the graph. No inflection points. Slope never becomes 0. When do we say graph takes a turn? When slope becomes 0. So slope never becomes 0. So maxima or minima does not exist. There are no inflection points. Next, the third one, find x and y intercepts. At x is equal to 0, y is equal to 4, substitute x is equal to 0. And at x is equal to minus 2, y is equal to 0. So the graph passes through 2 points, 0, 4 and minus 2, 0. As x tends to minus infinity, y tends to minus infinity. When you take large negative values for x, y also becomes large negative value. And as x tends to plus infinity, y also tends to plus infinity. When x becomes large, y also becomes large. Now we have all the information required to draw a graph. So what information do we have? The graph is a straight line. How do we know the graph is a straight line? Slope is a constant. Y increases as x increases at a constant rate. And this straight line passes through these 2 points, 0, 4 and minus 2, 0. This straight line extends from minus infinity to plus infinity. Okay, now let us draw the graph. So we have all the information required to draw the graph. So I'm going to draw the graph now. The graph is a straight line. The graph passes through 2 points. What are those 2 points? 0, 4 and minus 2, 0. This is minus to 0 point, and this is 0 comma 4 point, and the graph is a straight line. And the graph is a straight line passing through these points. That's it. This is the shape of the graph. So we don't need data points. At x is equal to 1, what's the value of y? At x is equal to 2, what's the value of y? So we don't need data points, and we don't need to join them to draw the graph. Just we understand the qualitative behavior of the graph, and then we draw it. That's it. Similarly, let's look at one more example. Now, look at this example here. Y is equal to 3 minus 2x. Y is equal to 3 minus 2x is a function. Let's see how to draw the graph. So first thing is to find the slope of the graph. What do you get? Slope of the graph is minus 2. It's negative, constant. What it means is y decreases as x increases at a constant rate, at a uniform rate. Of course, the graph is a straight line because y decreases at a constant rate as x increases. The graph has to be a straight line. Slope never becomes 0, so the graph has no turning points, no inflection points. And when x becomes 0, y is equal to 3, and y is equal to 0 at x is equal to 3 by 2. Okay, x and y intercepts. As x tends to minus infinity, y tends to plus infinity. Okay, for negative large values of x, y becomes positive large value. And similarly, as x tends to plus infinity, y tends to minus infinity. Now draw the graph. The graph passes through 2 points on y-axis and x-axis, 0, 3 and 3 by 2, 0. These are the 2 points through which the graph passes. The graph is a straight line. The graph is a straight line passing through these 2 points here. You know, as x becomes plus infinity, y becomes minus infinity. As x becomes minus infinity, y becomes plus infinity. These are straight line graphs, very simple graphs. Let's look at one more. Take this function, y is equal to x square. Y is equal to x square. Let's look at this graph. Find out the slope. dy by dx. dy by dx is equal to 2x. Look at the slope. It's not a constant. Slope is not a constant. For positive values of x, slope is positive. For negative values of x, slope is negative. Y is always positive. When x is positive, y is positive. When x is negative, then also y is positive, which means the graph comes in first and second quadrant. For positive values of x, y is positive with first quadrant. For negative values of x, y is again positive, second quadrant. For negative values of x, slope is negative. For positive values of x, slope is positive. There exists an inflection point here. Slope or dy by dx is equal to 0 at x is equal to 0. At x is equal to 0, second derivative becomes positive. Look, d square y by dx square is equal to 2. Differentiate this. Find the derivative of dy by dx. You will get 2. So second derivative positive, first derivative 0. Means what? At x is equal to 0, y becomes minimum. That can be understood from the function itself. For all positive values of x, y is positive. For all negative values of x also, y is positive. It means y is always positive for x not equal to 0. For x not equal to 0, y is always positive. It means for x is equal to 0, y is 0. That's the minimum value. So if at x is equal to 0, y is minimum and that minimum value is 0. So inflection point does exist here. At x is equal to 0, y is 0. And the third one, as x tends to, we got x-intercept, y-intercept, the graph passes through origin. As x tends to plus infinity or minus infinity in both the cases. As x tends to plus infinity, y tends to plus infinity. As x tends to minus infinity also, y tends to plus infinity, because for negative values of x, y is positive. For negative large values of x, y is positive. So y tends to plus infinity when x tends to plus infinity, and also when x tends to minus infinity. Now let's draw the graph. So the graph is in first and second quadrant. The slope becomes 0 at x is equal to 0. At x is equal to 0, y is 0. So the graph passes through origin. Is the graph a straight line? No, the graph is not a straight line. Why is the graph not a straight line? Because slope is not a constant. Okay, look at dy by dx here. For positive values of x, as x increases, slope also increases. Slope increases means what? Y increases at an increasing rate. Look, y increases, but not at a constant rate, because slope is not a constant. Here slope is not a constant. As x increases, slope increases. Slope increases means what? The rate of increase in y increases. As x increases, y increases, but at an increasing rate. Y increases at an increasing rate. So for positive values of x, slope is positive and increasing. For negative values of x, slope is negative. It means as x increases, y decreases. For negative values of x is increasing, y is decreasing. For large negative values of x, magnitude of slope is high. As magnitude of x decreases, as x comes close to 0 from the left side, the graph becomes flat. Okay, so at x is equal to 0, it takes a turn. Y becomes minimum. So this is the shape of the graph. Okay, similarly, we can draw shape of one more graph. Let's look at this function now. Y is equal to x square plus 2. The shape of the graph is same as the previous case. Slope you are getting same. Slope is 2x. Right. There exists an inflection point. At x is equal to 0. Slope is 0. Y is minimum. You can verify it. Y is minimum. And at x is equal to 0, that minimum value is equal to 2. Substitute x is equal to 0 here. The minimum value of y is equal to 2. It means the graph, the difference between the previous case and this case is that there is only a shift in the graph by 2 units up. For every value of x, for every value of y in the previous example, add 2 now. For every value of y in the previous example, add 2 now. So the shape of the graph is not going to be different than the previous example. It is same. The only thing is that the graph has shifted up by 2 units. So like this we can draw graphs. Let's take some trigonometric functions. Take y is equal to sine x. X is the angle, y is the ratio of sides in a right angled triangle. Take y is equal to sine x. Find its slope. Dy by dx is equal to cos x. And at x is equal to, look at the range from 0 to 2 pi. Let's draw the graph between in one cycle. One cycle means 0 to 360 degrees, 2 pi. So slope becomes 0 at 90 degrees. At x is equal to pi by 2. Slope is 0. At x is equal to 3 pi by 2, that is 270 degrees. Also slope is equal to 0. We know sine 90 degrees is equal to 1. Sine 270 degrees is equal to minus 1. So the maximum value of sine x is plus 1. The minimum value of sine x is minus 1. So y maximum is equal to plus 1 at x is equal to 90 degrees, pi by 2 radians. Y minimum is equal to minus 1 at x is equal to 3 pi by 2. That is at 270 degrees. Okay, so the limits of sine x, minus 1 and plus 1. Okay, so it doesn't go to infinity. Okay, y never becomes infinity. Y is always finite. It always lies between plus 1 and minus 1. Its maximum value is plus 1. Its minimum value is minus 1. The graph always lies between this plus 1 and minus 1. Okay, well, if you draw the graph, it looks like this. This is x is equal to 0. At x is equal to 0, y is 0. The graph passes through origin. Look, y increases. Y means sin x. Y increases. It means sin x increases. And sin x becomes maximum at x is equal to pi by 2. Sin x is increasing, but look at the slope. Look at the slope of the graph. I mean, slope of the graph means cos x. Slope is maximum at x is equal to 0. Slope decreases. Draw a tangent. Keep drawing a tangent. Slope becomes 0 at 90 degrees. That means cos x becomes 0 at 90 degrees. Pi by 2 radians. So slope is decreasing. Sin x is increasing, but sin x is increasing at decreasing rate. As x increases from 0 to pi by 2, y increases at decreasing rate. For greater than pi by 2, for x greater than pi by 2, y decreases. Slope is negative. For angle greater than 90 degrees, you know cos theta is negative. So slope is negative, y decreases. Y decreases at increasing rate. Y becomes 0 at x is equal to pi. After that, y takes negative values between pi and 2 pi. You know, y is negative and y becomes minimum at x is equal to 3 pi by 2. You know, the minimum value of y is minus 1, the maximum value of y is plus 1. y becomes minimum at x is equal to minus 1. And after that, y increases, becomes 0 when x is equal to 2 pi. This is what happens in one cycle in 360 degrees. X increases, y also increases from 0 to pi by 2. So from point O to A, y increases, but slope decreases. Sin x increases, cos x decreases slope. From A to B, sin x is positive, but its slope is negative. Okay. Slope means what? Rate of change in sin x. Rate of change in y is negative from A to B. Okay. From B to C, sin x is negative, its slope is also negative. From C to D, sin x is negative, but slope is positive. Look, from 3 pi by 2 to 2 pi, y is increasing as x is increasing. It means the slope is positive. Okay. So this is how we understand the qualitative behavior of the function and draw the graph. Let's draw one more graph. Or let's draw the graphs of the functions for which we found maxima and minima in the last video. In the last video, we have taken some functions and found maxima and minima. The first example that we discussed was y is equal to x square minus 4x plus 7. For this function, we found maximum value of y or minimum value of y. Let's go back and check. Look at this. Y is equal to x square minus 4x plus 7. We found that at x is equal to 2, y becomes minimum. I'm not going to do this again. At x is equal to 2, we already know y is minimum for this function. Slope dy by dx is equal to 2x minus 4. At x is equal to 2, y is minimum. You can find that minimum value by substituting x is equal to 2 here. So minimum value is 2 square minus 4 into 2 plus 7, 3. Minimum value of y is 3. And remember the checkpoints. As at x is equal to 0, y is equal to 7. At x is equal to 0, y is equal to 7. And y becomes 0 when x square minus 4x plus 7 is equal to 0. I don't think y becomes 0 anywhere. You will get imaginary values for x. The minimum value of y itself is 3, right? So y does not become 0 anywhere. So at x is equal to 0, y is equal to 7. So slope is 0 at x is equal to 2. At x is equal to 2, slope is 0. For x less than 2, look at the slope. Slope we have 2x minus 4. For x less than 2, slope is negative. For x greater than 2, slope is positive. Positive, and as x increases, slope increases. As x increases, slope increases. Here also increases. It means magnitude of the slope decreases or slope increases. It becomes less and less negative. As x tends to infinity, y tends to infinity. As x tends to minus infinity, also y tends to plus infinity. Look, x square. This is minus 4x. For large values of x square dominates 4x. Okay, x square is much greater than x. So y is positive. When x becomes large negative values, y is positive. When x becomes large positive values, also y is positive. Y never becomes negative. The minimum value of y is 3. Now let's draw the graph. At x is equal to 0, y is equal to 7. So this point is 0, 7. At x is equal to 2, y is equal to 3. At x is equal to 2, y is equal to 3. Let's say this is 0, 2, 3 point. So up to this point, y decreases. Up to that point, y decreases, becomes minimum there, and then increases. So this is the shape of the graph. This is the shape of the graph. Like this, we can draw graphs of many functions. We discussed one more example in maxima and minima. So let's draw the graph of that function. Look at this. At x is equal to 3 by 2, we got y maximum. At x is equal to 3 by 2, y is maximum. So let's draw the graph of this function. Y is equal to 3x minus x square. Y is equal to 3x minus x square. So slope 3 minus 2x. At x is equal to 3 by 2, y is maximum. Okay, substitute 3 by 2, you will get maximum value of y. So 3 into 3 by 2 minus 3 by 2 whole square. So this is 9 by 2 minus 9 by 4, which is 9 by 4. Maximum value of y is 9 by 4. At x is equal to 0, y is 0. And there is some other value at which y becomes 0. Okay, that is at x is equal to 3. At x is equal to 3 also, y is 0. So the graph cuts x-axis at 2 points. One is at origin and the other is at x is equal to 3. At x is equal to 3 by 2, y is maximum. And you can see from the function as x tends to minus infinity or plus infinity, in both the cases, x square dominates 3x. So the graph y tends to, in both the cases, y tends to minus infinity. So if you draw the graph now, At x is equal to 0, y is equal to 0, the graph passes through origin. At x is equal to 3 by 2, y becomes maximum. At x is equal to 3, y becomes 0. Okay. And look at the slope. Slope is not constant. Slope is not constant. Slope is positive for x less than 2, x less than 3 by 2. For x less than 3 by 2, slope is positive but decreasing. For x greater than 3 by 2, slope is negative, but its magnitude increases. So the graph comes like this. It's not a straight line graph because slope is not a constant. This is how the graph will be. Okay. At x is equal to 3 by 2, y is maximum. Like this, we can draw the graphs of different functions. Let's look at the graphs given by this application here. For the same functions, we have drawn the graphs. Let's draw the graphs in this application. Let's look at the function we have taken just now. Y is equal to 3x minus x square graph. Look at the graph. Look at this graph here. Graph passes through origin. Graph is passing through origin. And graph is passing through the point 3, 0. Y becomes maximum at 3 by 2. At x is equal to 3 by 2, y becomes maximum. Okay. So this is the shape of the graph that we have also drawn. Similarly, you can look at the graphs of various functions. Let's look at one more. X square minus 4x plus 7. X square minus 4x plus 7. Let's look at this graph here. Look at this graph. The graph passes through the point 0, 7 here. And the graph becomes minimum. Y becomes minimum at 3. The minimum value of y is 3. At what value of xy becomes minimum? At x is equal to 2, right? At x is equal to 2, y becomes minimum. The minimum value of y is 3. Okay. Like this, we can draw graphs of many functions. Let's draw the graph of y is equal to sine x. Take this trigonometric function. Look at this sine x graph. The limits of sin x are +1 and -1. Sin x becomes maximum at +1, minimum at -1. Sin x increases from 0 to 1. It decreases from 1 to 0, and then from 0 to -1. Again increases from -1 to 0. The behavior repeats in every cycle. So one more thing that I want to tell you here is this. Look at the graph close to x is equal to 0. So I mean, for small values of x, look at the shape of the graph. For small values of x, I mean 0.05 radians, 0 to 0.5 radians, or minus 0.05 radians to 0.05 radians. In this region, for small values of x, look at these boxes here, these boxes squares. The graph is diagonal of the square. The graph is drawn along the diagonal of the square. The graph is making an angle 45 degrees with x-axis. So slope is equal to 1, tan 45 degrees. Slope is equal to 1. So what I am trying to say is y is equal to x when only for small values of x. So as x tends to 0, what I am trying to say is sin x is approximately equal to x, or y is approximately equal to x. If you find sine 1 degree, you will get 1 into pi by 180, because 1 degree means how many radians? Pi by 180. 1 degree means pi by 180. So sine 1 degree is equal to pi by 180. So what I am trying to say is 1 degree is pi by 180. Sine 1 degree value is also approximately equal to, so very close approximation. After the decimal point, 4 digits are same. Sine 1 degree is also equal to pi by 180. Sine 2 degrees, because 2 degrees is 2 pi by 180. Sine 2 degrees is approximately equal to 2 pi by 180. So for small values of angle, you can say generally when angle is less than 5 degrees. For small values of angle, sine theta is approximately equal to theta. Similarly, tan theta also you can see. Okay, for small values of theta, sine theta is approximately equal to theta. Like this, you can draw graphs of many functions. So while drawing the graphs, first, before drawing the graph, we need to gather all the information required to draw a graph. What do we mean by all the information? Is y increasing or decreasing, at what rate, constant rate or increasing rate or decreasing rate? Are there turning points in the graph? Okay, what are x-intercept, y-intercept? So such information you have to gather first. You need to form the shape of the graph in your mind based on the information that you gathered, and then put it on the paper. Okay, so this is how we draw the graph. That's all in the calculus part 1, that is differentiation. This is the calculus part that is required to understand concepts in physics. I'm talking only about differentiation. So I would say that's all in calculus part 1, required to understand concepts of physics. In the next video, we are going to discuss calculus part 2, that is integration. So we will discuss what is integration, how do we do this integration, when do we do the integration in physics. Okay, some applications of integration. What is the meaning of integration on a graph? So these things we are going to discuss in calculus part 2.